Standard 30 and 31 are exponential functions standards. 30 is going to be about graphing exponential functions that are both growth and decays. So the first thing we're going to do is just take a minute to talk about exponential functions in general. What is it? What does it look like? So on a graph, your exponential function is going to kind of be a one-sided curve. So on the right side here, it's going to go up and up and up forever. And on the left side, it's going to climb super close to this line, which is the x-axis, but it's never actually going to touch it. So this is an example of an exponential growth because it's going up from left to right. Some functions, if it's considered a decay, that function will start up here and it will go down from left to right. That would be a decay function. They're going to have this thing called an asymptote. An asymptote is a line that the graph will never touch, but it gets really, really close to. In this case, our asymptote is the x-axis. So this horizontal asymptote is at y equals 0. A function that is exponential is going to look like this. It's going to be in this form, where y is over here on the left, and x is up in the exponent, which is why it's called an exponential function. The two letters a and b, a is the y-intercept, or the initial amount, and b is the rate. It's the rate of growth or the rate of decay. If that b value is bigger than 1, it's going to be a growth. If it stays at 1, that means it's going to stay the same. So if b were 1, it would stay the exact same all the time, which would just be a flat line. If it's a decay, that b value is going to live between 0 and 1. So think fraction, decimal, in between 0 and 1. If a is less than 0, this function is going to be flipped over the x-axis. Now, what does that mean, less than 0? That means a is negative. If a is negative, instead of being a growth function like so, what you're going to see is a function upside down. This is what it would look like if a is less than 0. Okay, so if you have a negative a value or a negative initial amount, it's going to flip that upside down. Okay. Skill 1 is just identifying if a function given to you is a growth or a decay. So looking at these functions, are they growths or decays? This y-intercept, although it's great, it's helpful, it does not tell us growth or decay. So we're looking inside the parentheses here. Because b is bigger than 1, this is a growth function. Here, b is not bigger than 1. b is in between 0 and 1, so this is a decay. Here, I finally have my negative a value, which just means it's going to be upside down. It does not tell me growth or decay. And inside here, 5 over 4 is 1.25 as a decimal, so it's a growth. B is bigger than 1. Okay, here, this is way bigger than 1, that 200, but that doesn't really tell me anything about growth and decay. It tells me the y-intercept. This 1/2 tells me if it's a growth or decay, and because b is a number that's in between 0 and 1, it's a decay. Okay, now let's spend the rest of the time actually putting these things on the graph. Let's turn the page. The very first thing we're going to do is we're going to talk about what numbers we're going to use for the x. You can use any number you want when you're using a table to graph a function, whether it's linear, exponential, quadratic, whatever. You can use whatever numbers you want. So we're just going to use -2 to +2. This is not going to be super fantastic, but we're going to do the best that we can. Okay, so how do I type this into my calculator? I'm going to type in 4 to the negative second power and put that here. So I'm just putting negative 2 in for x. So I'm just typing it into my exponent. 4 to the negative second power is 0.06. Now you might be thinking, how am I going to get that on the graph? Don't worry, we'll go over that. Then I'll type in 4 to the negative 1. I'm using this upside down V button for my power. Negative 1, just 0.25. 4 to the 0 power, well, anything to the 0 power is 1. 4 to the first power is 4. 4 to the second power, that's 16. Okay, now let's try to put this on the graph. This one's going to be super hard to put on the graph, so let's come down to this one. Negative 1, and then I've got to go up 0.25. Okay, well, halfway is 0.5, so I'm just going to put my dot underneath that. It's going to be really close to that line. 0, I'm going to put a dot at 1. 1, I'm going to put a dot at 4. And 2, here's 10. I don't know, 16 might be up here somewhere. So what we know about exponential functions is that on this side, yep, they're going to keep going up and up and up and up and up forever. And on this side, they're going to just hug the x-axis. It's never going to go across the x-axis, so we don't want to cross down underneath that, but that's as good as I can get. Okay, we're going to hang on to this one for just a second. So here's an example of a growth function. Notice that there was no a value here. So this is y equals, my a value was actually 1, and then my b value was 4 to the x, which just meant that my y-intercept was 1. Yep, it was 1. So the same thing's going to happen here. My a value is 1. My b value is just 1/3. So I'm going to have a decay on this one. So let's see what a decay is going to look like. We're going to use the numbers again, negative 2, negative 1, 0, 1, and 2. And then I'll use my calculator. When I use my calculator for this one, that 1/3, I'm going to put it in parentheses just so that the calculator knows I want the whole thing to the power. 1 divided by 3 to the negative second power is 9. 1 parentheses 1 divided by 3 to the negative first power. Hopefully you're not surprised by this, is 3. Anything to the 0 power is 1. To the first power is 1/3, which is going to be 0.333. And then 1/3 to the second power is 0.04, I'll say, 0.04. That one's going to be pretty hard to graph. Okay, negative 2, 9, it's going to be right here. Negative 1, 3, 0, 1, 1.3, and then I'll just continue super close to the x-axis here. Close as I can. And there's your exponential decay. And it's a decay because my b value is in between 0 and 1. So this was 1 times 1/3 to the x. So my b value was 1/3, which makes it a decay, and my a value was 1, which means my y-intercept is 1. Okay? Now I did skip over number 2 just for a minute. This would also be an example of a decay, but I skipped over number 2 because I just wanted to write down really quick for you that this would be y equals negative 1 times 1.5 to the x power. So when you graph this, this is going to be one that's flipped upside down. Okay, so we want to make sure that we graph this one correctly. So when you type it in, you actually don't have to type the negative 1. Your calculator will know what you're doing. we're just going to go ahead and type in negative 1.5 to the negative second power. So that's negative 0.4. Now I'll do it again. Negative 1.5 to the negative first power. Negative 0.6. Negative 1.5 to the 0 power is negative 1. So now you might be thinking, wait a minute, I thought anything to the 0 power was positive 1. Well, that goes back to this. Anything to the 0 power is 1, and then you have to multiply it times the negative 1 that's in the front. So it's a little bit different, a little tricky there. Negative 1.5 to the first power, negative 1.5, and then negative 1.5 to the second, negative 1.5 to the second power. All right, now we're ready to graph this. Okay, negative 2.4. Put that really close to the axis here. Negative 1, go about halfway. 0, negative 1. Positive 1, negative 1.5. 2, negative 2.25. So this is a slower growing function. And there we go. But you can see it has been flipped upside down. Its mirror image would be this way. So it's a growth. Just a growth upside down. Okay, last little bit will be in the next video. That's all for this one. That gets you to a level 3, and then the next video will show you how to get a level 4 by adding in that A value.